In this chapter, we're going to look at vector representations, both vector representations of documents and of words. We're going to convert both documents and words to vectors. Vectors are sequences of numbers, and these vectors allow for comparisons because you can measure the distance between them. This means they're useful for finding similar documents and words. So in this chapter, we're going to first look at document vectors, and we're going to do document similarity with TF-IDF and Gensim. Then we're going to look at word vectors, and we're going to play with the word vectors from Google, and we're going to learn our own word vectors in Gensim. So first, document similarity with TF-IDF and Gensim. Consider a vocabulary of 50,000 different words, which is pretty common for English. So we have 50,000 different words, and we're going to assign a number to each of those words between 0 and 50,000. And any word that's not in that vocabulary, we can just assign it to an unknown symbol, or a symbol that indicates unknown. So you could then represent a document by putting a 1 in that position for every word in the document and leave 0 for all the other values. If you did this, you could then compare the similarity of two documents by looking at the similarities between their two vectors. So you're essentially just looking at the word overlap. But we can do better. So what if a particular word occurs a lot in a document? So instead of just a 1 or a 0, we want to count the number of times the word occurs. And this is called term frequency. It's the TF portion of IDF. So now we have words that occur frequently have a higher weighting in this vector, which should help, but rare words should be more important for characterizing documents. That brings us to the IDF portion. So what we're going to do is we're going to multiply the term frequency by the inverse document frequency. So we multiply each TF value by a measure of how common it is in a set of documents. And this is that inverse document frequency. So we get the inverse document frequency for a particular word by dividing the total number of documents by the number of documents containing that word or term. And then we take the log of that. Here we have the equation. IDF for term T in a document is the log of the number of documents divided by the number of documents with that term in it. So let's look at how we can do this with a Python library called Gensim. So Gensim is a software library. We can go there and take a look at it. So here it is, free to download and use. So you install Gensim here, easy install or pip install, just like we've been doing. So the first thing we're going to do is import Gensim. We get a warning about the pattern library not being installed, but we're not using that at the moment, so let's not worry about that. So we're going to create a set of raw documents, which are just text, lists of strings. So we have I love tacos, she ran with the chicken, I don't choose to take a nap, the nap chooses me, that man is nice as pie with ice cream, this pizza is an affront to nature. So we have a list of 5 documents. We're going to use NLTK as our first pre-processing step. We're also going to define a helper function to get tokens. And one way that we're going to represent documents in Gensim is as a list of tokens. We'll see later we're going to do it as a bag of words, but for the moment it's going to be a list of tokens. And we're going to create this list by calling our getTokens function on each text in the raw documents. On each of those documents in the raw documents, we're going to use list comprehension. So here we are. The first one is I love tacos. It's just a list of tokens, and note that tacos and period got separated as we saw previously with tokenization, and that's how that works. So next we're going to create a dictionary. So we're going to take our documents that we created, which are lists of tokens, put it into Gensim to create a dictionary, which will assign to each word a number. That makes it easier to work with. So what we have is 31 words in this dictionary. 0 is I, 4 is chicken, 9 is chooses, all of the words that we mentioned, period is 1. So what we can do is if we know the number for a token, we can call the dictionary directly, or we can use this ID2Token to get back our word. So here we have with. If we look up, 7 should be with. There it is. Yes, it is. Or if we know the word and we want the ID, we can use token to ID. We have ran. Let's confirm that ran is 6. There it is. Ran is 6. I mentioned before that one way of representing documents is as a list of tokens. So what we're going to use today heavily is called a bag of words representation. And this just boils down to the TF, the term frequency, and TF IDF. So it's called a bag of words because order is lost. So what we're going to do is take a document as a list of tokens and convert it into a bag of words. So here we have I love tacos, exclamation point. Exclamation point, if you recall, is not in our dictionary, so it will not show up. it will just be ignored. So we have the first word, I, occurs once. The next word, love, which is word number 2 in the dictionary, occurs 3 times. You see that here. Let's confirm that love is word number 2. There it is. Love is word number 2. It's listed 3 times. And we have tacos listed once. We can create a corpus where a corpus is a list of bags of words. So recall above, we created GenDocs as this list of tokens for each document. And we can convert each of those into a bag of words representation and make that a corpus so that our corpus is a list of bags of words. Here we are. So we see the first document here, then the next document. So it's a list of bags of words where each element in each bag of words is the word index with the number of times it occurs. Once we've done that, we can convert the whole corpus into a TF-IDF model. So we have a model, and just this num underscore NNZ is the number of tokens in the model. So we've created our model. What we can do now is show a document in text form, bag of words form, and TF-IDF. So we have GenDoc0, which recalls our list of tokens. Then we can look at it in the corpus form, which is the bag of words form. Then we can look at it as TF-IDF. We have I love tacos. So the value for I is lower, the first word, 0.37, because I occurs in a lot of documents. And so because of the inverse document frequency, it's going to be lower. But the value of love and taco are both higher because each of those only occurs once. And period is not there at all because it occurs in every document. And so therefore its IDF, inverse document frequency, is 1. When you take the log of that, you get 0. So it has a 0 value. We can do this same process for a new document. So we have I love pizza, convert it to a bag of words, and then we can run the bag of words for that document through our TF-IDF model. So note that it's similar to the one above, except it's pizza instead of tacos. And pizza is number 27. This next box I'll leave as an exercise for you guys. It's a mathematical confirmation that what TF-IDF is doing in Gensim is what we described in the slides. So we can create a similarity measure in this TF-IDF space. So what we're going to do is create a similarity object. And the first argument we pass in is a file for external storage in case everything doesn't fit in memory. And then we put in our corpus in TF-IDF form. And finally, the num features, which is the lengths of our vectors. Print that out. So it says, okay, we've got a similarity index with 5 documents and 0 shards. So the shards is if it's too big to fit in memory. What we can do now is create a query document and convert it to TF-IDF. Run this. So we have the query document chicken with tacos love. Now that we've created that query document, we can show the set of documents that are similar to that document. And we see the first document is similar. It's the most similar. The second document is second most similar. And the fourth document is somewhat similar. Both document 0 and 1 match with 2 words each. And document 1 matches with the words with as one of those words. But that word occurs more times in the corpus, so that document is less important. That's why it's not as good a match as the first document. And there's only one overlapping word with the fourth document. Look at that one more time. Our query document was chicken with tacos love. And if we go back and look up above, chicken with tacos love matches 2 words, love and tacos in the first document, 2 words, with and chicken in the second document. But because the word with also occurs in the fourth document, the word with is less discriminative. And so that's why the second document is less of a match. The fourth document is somewhat of a match because it contains the word with. But since that word, as we said before, is not particularly discriminative because it occurs in more than one document, that value gets lower still. As an exercise, you can take a document like an email or news article, break it into sentences and run each sentence through as an individual document. And now we can find similar documents based on query documents.